So what we were doing was way too much work. So the whole purpose is to see there's easier ways to do things and faster ways to do things. So we know this. This is something that you must have memorized. It's one of our standard Maclaurin series that we should know. It's x to the n plus dot, dot, dot. In summation notation, again, you need to know the summation notation. So we'll probably have a quiz where you have to tell me the standard series for those 5, I think I gave you. Sine, cosine, e to the x, 1 over 1 minus x. The rest can be derived from those. So that's going to be x to the k. Now look, we want plus x squared. If I replace x with minus x squared, so we'll call this g of x. So if I do g of minus x squared, that will replace every x with minus x squared. And we will get this, 1 plus minus x squared plus minus x squared squared plus minus x squared cubed plus dot, dot, dot. I forgot the plus there. Plus, I only need the first 4 terms. So to do the problem correctly, that's all I wanted. And then the summation notation would be this. Minus x squared to the k. So let's simplify all this and we'll get our final answer. This will be 1 minus x squared plus x to the 4th minus x to the 6th plus dot, dot, dot. And in this formation, it's going to be minus 1 to the k and x to the 2k. And why is it that way? Just to show you, minus x squared to the k is the same as negative 1 times x squared to the k. And you raise each one to the k power, and that's how we get that. Okay? So there is that much. They want the interval of convergence, and here's how we do that. And this is where some of the stuff we were having trouble with, inequalities. Yesterday we were having trouble. So we know the interval of convergence for this is that, right? But we replaced x with minus x squared. So I'm going to do this. I can multiply everything by negative 1. But if I do that, the inequality flips. So I'm going to get 1 x squared negative 1. And I'm just going to rewrite it the other direction. Now, let's talk. So what values of x will work here? Well, x squared is always going to be positive, never negative. So we can do this. Now, the square rooting, let's look at x squared, see what it looks like. The graph of x squared looks like this, right? And you want the y value, let me circle this, to be less than 1. Well, 1 on this graph it's not accurate. But what values of x will get you values less than 1? It's going to be between negative 1 and positive 1. So this will simplify. I lost my black color here. To be negative 1 to 1. So it's not going to change that interval. I'm actually looking up videos on working with inequalities and square roots and things like that. And there's actually things you can do with this. But that kind of explains how you get negative 1 to 1 on that. Okay, so that's that one. We are done.